Hi, I want to talk to you about another method on how to solve quadratic equations. And this method is called the method of completing the square. And I want to show you an example first that actually can't be done by the methods that we know and show you kind of the idea behind completing the square. So if you look at x squared minus 8x plus 16 equals 3, and you want to solve that by factoring, you might start by subtracting 3 from both sides to get x squared minus 8x plus 13 is equal to 0. And then you would try to find the factors of 13 whose sum is 8. But we know that is impossible, right? Because 13 is only 1 in 13 and that sum is 14. But this is something that is only special in this particular type of problem. Notice that x squared minus 8x plus 16 actually factors. And if we factor that, we would get x and x. The factors of 16 whose sum is 8 would be 4 and 4, and we know both signs are the same because of this sum, and they're both negative. So x minus 4 times x minus 4 is really x minus 4 squared is equal to 3. And then we can apply the square root property that says x minus 4 is equal to plus or minus the square root of 3. And then we can add 4 to both sides to get 4 plus or minus the square root of 3. Now, those would be our solutions, and it only works when we have what's called a perfect square trinomial on one side of the equation equal to a number. Okay? Now most equations don't come in that form, so we have to talk about how can we get a perfect square trinomial. So just kind of the idea behind completing the square is that we're going to actually rewrite the equation so that we can apply the square root property to solve it. So let's look at perfect square trinomials and see what they are. Perfect square trinomials always come from a binomial squared. So x plus 5 squared. Remember, you can do x plus 5 times x plus 5 if you like, or there is a pattern for squaring. You get x squared plus double the product, which would be double 5x, which is 10x, plus 25. X minus 7 squared is x minus 7 times x minus 7, or x squared minus 14x plus 49. X minus 3 squared is x minus 3 times x minus 3, and it's x squared minus 6x plus 9. So the thing to note here is how can we determine this constant term from this coefficient of x? First, notice that the last sign in a perfect square trinomial is always positive. And then the question is, if I know 10, how can I get 25? Or if I know 14, how can I get 49? If I know 6, how can I get 9? Well, 25 we know is 5 squared, and 5 is half of 10. 49 is 7 squared, and 7 is half of 14. 9 is 3 squared, and 6, or 3, is half of 6. So the relationship of the constant term to the middle coefficient is that it is half of the middle coefficient squared. Okay? Now, you're saying, why do I need to know that? Because what's going to happen is you're going to be given a binomial, really in the process of solving this equation, that you've got to transform into this perfect square trinomial. So if I have a binomial of the form x squared plus bx, that plus can be plus or minus depending on what b is, the perfect square trinomial may be obtained by adding half of b squared. And that's the process of completing the square. Let me go back and do some examples with that. So for instance, if I have x squared plus 4x, when I need to add to get a perfect square trinomial. So what I would have to do is take half of 4 is 2, and square it. 2 squared is 4. So if I add 4, I get a perfect square. How do I know that? Because it factors as x plus 2 times x plus 2. What if I have x squared minus 12x? What number do I need to add to get a perfect square trinomial? Well, we would take half of 12, which is 6, and square it, which is 36. And I know that that factors as a perfect square because the factors of 36, whose sum is 12, would be 6 and 6, and both signs are negative. So notice in the factorization, it was a number that I had to square to get this last term that goes in the binomial, and the sign of the middle coefficient is the sign of those binomial factors. Let's do one more. What if I have x squared plus, I don't know, let's say 18x. So what number would I have to add to that to make it a perfect square trinomial? Half of 18 is 9. 9 squared is 81. So in my binomial, it would be x plus 9 times x plus 9. Okay? So let's look at first the steps that we're going to use to solve quadratic equations by completing the square, and then we'll do some examples. So the first thing that you're going to want to do is to get the terms with the variable on one side of the equation and the constants on the other. The leading coefficient of the variable must equal 1. If not, you have to divide through by that coefficient. That's because all those previous examples that we did with the perfect square trinomials, all of those things only work if the coefficient of the square term is 1. Then you're going to complete the square on the left and add this number to both sides, so that completing the square is where you're going to add half of b squared. Then you're going to factor that perfect square trinomial as a binomial squared, simplify the other side, and then you're going to apply the square root property to solve the equation. So let's look at some examples to solve by completing the square. So x squared minus 2x plus 5 equals 9. The first thing we need to do is subtract the 5, because what we want are just the variable terms on the left. Okay, now this is where we're going to use completing the square, because we want a perfect square trinomial on the left. So we're going to take half of 2. Half of 2 is 1, and 1 squared is 1. We have to add that number to both sides. Then x squared minus 2x plus 1 factors as x minus 1 times x minus 1 is equal to 5. Or better yet, we can write that as x minus 1 squared is equal to 5. So now we can apply the square root property that says that x minus 1 is equal to plus or minus the square root of 5. So if we add 1 to both sides, we will get x is equal to 1 plus or minus the square root of 5. So our solutions are 1 plus the square root of 5 and 1 minus the square root of 5. Now, if you had to approximate it, you could. You'd have to use your calculator. And 1 plus the square root of 5 is approximately equal to 3.24. And 1 minus the square root of 5 would be equal to negative 1.24. Okay? Now, you would not write those answers in my math lab unless it said to enter the approximated values. But just as to solve, you're going to enter these exact values. But you can check the 3.24. If you plug it in and square it, subtract 2 times that value and add 5, you're going to get approximately 9. The same thing with the negative 1.24. Okay. Another example, y squared plus 10y plus 18 equals 0. So again, we have to start by getting our variable terms together and the other term on the other side. So we would subtract 18 from both sides. Now we're going to complete the square. The most common mistake I have here is students forgetting to add it to both sides. So remember the rule. What you do to one side, you have to do to the other. So y squared plus 10y, to make it a perfect square trinomial, we take half of 10. Half of 10 is 5, and square it, so we get 25. And we add that to both sides. So y squared plus 10y plus 5 is going to be y plus 5 times y plus 5, or we can write that as y plus 5 squared is equal to 7. So we can apply the square root property to get y plus 5 equals plus or minus the square root of 7. We subtract 5 from both sides to get negative 5 plus or minus the square root of 7. So our solutions are negative 5 plus the square root of 7 and negative 5 minus the square root of 7. Okay? Another example I wanted to do where you don't have a 1 on the x squared, but again, the first thing we need to do is add the 21 to both sides. Now we need to get a 1, so to get a 1 we divide by whatever coefficient this happens to be, which is 3. So thank goodness everything's easily divisible by 3. 24 divided by 3 would be 8x, and that's equal to 21 over 3, which is 7. Now we have to complete the square, so we take half of 8, which is 4, and squared is 16, and we add that to both sides. So we would get x minus 4 times x minus 4, or x minus 4 squared, is equal to 23. So applying the square root property, we get x minus 4 equals plus or minus the square root of 23. And then we can add 4 to get 4 plus or minus the square root of 23. So our solutions are 4 plus the square root of 23 and 4 minus the square root of 23. Okay? So this is completing the square. It's a good method to use if you have a 1 on the square term and this middle term is even. If this middle term is even, when you divide it by 2, you get a whole number. If it is an odd number, when you divide it by 2, you get a fraction. So it's not always the best method to use, but it is a method that will solve any type of equation. You can also get imaginary solutions here, or you can get rational. If this happened to have been the square root of 25, then you would want to go ahead and simplify that to be 5 and combine 4 plus 5 and 4 minus 5. It just depends on what that number is. Okay? But if you have any questions, please don't hesitate to contact me. Thank you.